Hello, and welcome to Waterton Glacier Science and History Week 2022. My name is Krista Mendeska, Science Communication Technician at Glacier National Park. I want to thank you for joining us today as we explore recent results from scientific research and conservation efforts in Waterton Glacier International Peace Park. In 1995, Waterton Glacier International Peace Park was designated as a World Heritage Site by the Convention Concerning the Protection of the World Cultural and Natural Heritage in recognition of Waterton Glacier as an area of outstanding universal value to people throughout the world. We want to respectfully acknowledge we are on the traditional and ancestral homelands of the Siksika, Satapi, Kootenai, Salish, and Quilispe people, whom we recognize as original stewards of this land and all the relatives within it. We honor with gratitude the people who have cared for this land throughout the generations and continue to maintain enduring connections to their traditional territories. This is our third day of a 4-day webinar series. Each day at noon, we will bring you a new presentation highlighting current research and conservation topics related to Waterton Glacier International Peace Park, selected from dozens of research projects conducted here in the heart of the crown of the continent. This park serves as an important natural laboratory for dozens of researchers, and we are excited to bring you a sampling of recent results throughout this venue. The presentation will last about 35 minutes with around 5 to 10 minutes allotted for questions at the end. You can click on the chat icon at the top of the screen to open the chat box and type your questions at any time during the presentation. Note that your questions and comments will be visible to all participants. You can also wait to ask questions at the end of the presentation. We will address as many questions as we can at that time. To improve your presentation view, you can click the triple dot More icon and select full screen to enlarge the view window and focus on content to hide speaker boxes. For live captioning, click the triple dot More icon at the top of the screen and select Turn on Live Captions from the drop-down menu. If you're using the web version of Teams, you might find these options down at the bottom of your screen. And today we are featuring the presentation titled Grizzly Bear Use of Army Cutworm Moth Aggregations in Glacier National Park, led by Erik Peterson, recent master's graduate from Washington State University. Erik discovered Glacier as an undergraduate in 2003 while volunteering on a bear DNA study, which planted a seed for himself as a young and aspiring biologist. His experience as a field biologist spans federal, state, and tribal agencies in Montana, Washington, Idaho, and Minnesota. In recent years preceding graduate school, Erik honed his knowledge and experience in bear ecology while working for Montana Fish, Wildlife, and Parks from 2008 to 2009 and Glacier National Park from 2010 to 2018. Erik's graduate research combines his passion for bear conservation with his love for the high country. Erik completed his Master's of Science degree earlier this year and spent the summer conducting fieldwork in the Canadian Rockies. And now we will turn the time over to Erik.
Okay, hello everyone. Thanks for attending and listening to what I have to say today. See, I'm just setting on my screen here. Can everybody see everything okay?
Yes, we can. Looks good.
Okay, sounds good. So yesterday, for those of you that attended, James talked about a butterfly in Waterton that lives in a very specific area and isn't found very commonly. And today I'm going to talk about a moth that has a similar story and that it's found in very specific habitat. And different from yesterday, this tiny little moth is actually a very important food source for a large muscular animal, grizzly bears. And so before I get going, this project was, I want to acknowledge sort of the collaboration that came together to pull this project off. It was a large endeavor to implement safely and effectively. And so I first would like to thank the Glacier National Park Conservancy for funding this research, Two Bear Air Rescue for their aerial resources, Glacier National Park and the National Park Service for years of employment, and for John Waller in particular, and then the rest of park staff for helping with the support the logistics of the study. Washington State University and Dan Thornton's Mammal Spatial Ecology Lab here at WSU for housing this project and providing me with the skills and knowledge to implement this project and carry it forward. And then also I want to recognize British Columbia's parks, provincial parks, and Parks Canada. This project originally was intended to be a transboundary study, but unfortunately due to COVID-19, we weren't able to carry out the work as we had intended. And then finally, I'd like to recognize Stephen Nam for lending his photographic eye to this project and helping to visually capture it. So this is really a migration story between moths and grizzly bears, and a lot of species migrate to improve their fitness or survival and reproduction. And so migration is effectively a method by which species migrate to exploit seasonally advantageous environmental conditions in distant areas. So there's lots of examples of this. Summer versus winter range. A good example is Wyoming and pronghorn antelope migration. There are vertical migrations. Mountain goats, in particular in the North Cascades, have to migrate vertically, in this case descending in winter to access their forage over the winter months due to heavy snowpack. And there's long distance migration, which are primarily flying, swimming, and nomadic species. The humpback whale is a great example of this, where they travel across the Pacific Ocean to get to very specific breeding areas. And so the army cutworm moth is a migratory species as well. And so, as James mentioned yesterday, again, it's about the size of a Canadian dollar. Its orbital, its spots on the wings, on the forewings that you see there, and the cream fringing on the hind wings are sort of distinguishing features of this moth, along with kind of a very woolly chest. And so army cutworm moths, which I'll refer to as ACMs from here on, they have a 1-year life cycle, and that begins right about now with eggs being laid in low elevation habitats. Those eggs will hatch and the larvae will come out this fall. Those larvae will then hibernate in the soil, and then in the springtime they emerge and will feed on vegetation in low elevation habitats, which are commonly dominated by agriculture. And that means that when they forage, they can they can create crop losses for farmers and hence are sometimes considered a pest. And so that's how most people know army cutworm moths. And so then in the month of June, after pupation occurs, the adults come out, and around July, they undertake this great migration. And during the months of July, August, and into September, the moths go to high elevation areas of the Rocky Mountains. And this is the period of time that I'm going to primarily talk about today. And in the fall, when those cool temperatures start hitting the mountains, the adults fly back to the plains again, like I said, to lay eggs. And then after they lay their eggs, the adults die. And so on the right here, on the upper, that's the larvae, and then the cutworm is below, and you can see some of the distinguishing cut marks on that vegetation. So a little bit about moth biology. So they have aggregating tendencies. So whether they're on the plains or up high in the mountains, the moths are aggregating in prodigious quantities, thousands and thousands of them. They metabolize wildflower nectar into lipids. And this causes their body composition to change from 15% fat to 70% fat over the summer months. And this is a video of what that looks like on a talus slope in Glacier. So as you can see, they're just everywhere, and it's just like, you know, you see videos of locusts in Australia or something. So these moths have just emerged from the talus. and they are now flying, and they're flying to get to alpine flower fields. And this is what it looks like when they're foraging on wildflowers up close. So I want to talk a little bit about grizzly bears, which I'll just call GB from here on for simplicity. So they're a generalist species. They have flexible habits and large home ranges. So that means that they can feed on a wide variety of food resources. They can use different habitats, and they need lots of area. And so on a summer like this, when we have sort of a wide berry crop failure, or not very good huckleberry production, grizzly bears are capable of being reflexive and shifting to other food resources to meet their needs. So they're a threatened species, and that's primarily due to the cumulative effects that are associated with humans, between roads, development, all sorts of those things which we're all pretty familiar with. And in the lower 48, their populations primarily live on federal lands these days. They hibernate for 3 to 6 months per year based on their age and sex of individuals. And because of that, during the active season, they have this mission to obtain calories to optimize their mass gain. So they have to catch up for lost time, essentially. And the large front shoulders and claws that they have facilitate access to food resources, including these army cutworm moths. And so like I said before, the ACMs are available to grizzly bears from July to September. And their fat content attracts grizzly bears to talus slopes. So in essence, grizzly bears are migrating vertically, going to these high elevation areas to feed on these moths that migrate horizontally and vertically great distance to get to these talus slopes. So it's a really cool phenomenon. That energetic, costly that cost of that travel is costly. So you know that food source needs to be predictable. And there, I mean, when we climb mountains, and then we reward ourselves with a cheeseburger. Grizzly bears are effectively doing the same thing. And so they have the capacity to eat 40,000 moths per day, which is equivalent to 20,000 calories. And this is an optimal food source. And when I say optimal food source, I've mentioned how they're full of fat, which they can be 70%, but they're also 25% filled with protein. So as far as mass gain, we know from the literature that the macronutrients contained by moths is super valuable to grizzly bears in optimizing that mass gain. And so this is a graph of their range. And during the summer months when they undertake the migrations, the moths fly both in an east and west direction towards the continental divide, which is marked in orange. And it just so happens that summer migratory range of theirs overlaps 2 occupied grizzly bear recovery areas in the lower 48, that being the Greater Yellowstone in northwest Wyoming and the Northern Continental Divide in northwest Montana, which is where Glacier National Park is. And so as we zoom in to the Northern Continental Divide ecosystem, we'll see first and foremost that, as Tara mentioned, that this is the ancestral lands of the Confederated Salish and Kootenai tribes and the Blackfoot Confederacy. So I just want to acknowledge that as well. And you can see that Glacier National Park is in the northern third of the ecosystem. And what's important about this study is that Glacier serves as the heart of this recovery ecosystem. So it contains roughly 40% of the population. And so grizzly bear survival on the fringes of the ecosystem is less due to those effects associated with humans. And so to understand, to support grizzly bear recovery and dispersal throughout the ecosystem and into Canada, it's important to understand the food resources that grizzly bears use. And in particular in Glacier, the Army cutworm moth is kind of a unique food resource that is not found across grizzly bear occupied range. And so that's why we're looking into it. And so when grizzly bears are foraging on moths, this is what that looks like. Here's a sow with a single cub of the year. She's feeding, and you might see a few white specks going off. That would be moths flying off in response to the disturbance. And so This is a foraging site, but also, as this next video will show, this is a food resource that grizzly bears are living at. So grizzly bears are living up high on these mountains. And here this cub of the year is trying to nurse the sow as the sow tries to sleep. And so some original research that took place in this park occurred in the early 1990s with Don White Jr. He earned his dissertation by going only to sites where we already knew that grizzly bears foraged on moths. These places came primarily from observations of park rangers and visitors. And so it was 6 or 7 sites that he went to and looked at grizzly bear use of cutworm moths. And so the focus of his 3 publications that he got out of this was looking at how they're using these sites, how long they're here, the energy resources that they get from feeding, and then lastly, sort of potential impacts that that humans can have when they're accessing these sites. And so that's all I'm going to talk about here. If you want to learn more, you can look those publications up. So my graduate work occurred from 2019 to 2021, and the goal was to increase our understanding of grizzly bear foraging in Glacier, and then perhaps apply that more broadly to the wider ecosystem and areas beyond. So we had 3 objectives, and one was to identify these grizzly bear aggregation sites across the park. Again, we did not know that wholly before this project started. Sorry, I had those mixed up there. And then secondly, to model basically where ACMs are across the park and available to grizzly bears. And then also to model or estimate grizzly bear foraging for ACMs. And we conducted, for objectives 1 and 3, we conducted separate modeling efforts to get at that, because where ACMs are found isn't necessarily where grizzly bears are always going to be found foraging on them. And so this is a brief outline of how we'll proceed from here. So I'll talk about ground and aerial surveys, and this will primarily get at the objective of identifying the grizzly bear used aggregation sites. And then I'll talk about both modeling efforts where we're modeling where ACMs are found and where grizzly bears are foraging. And then lastly, kind of to bring it all together, I'll talk about how we sort of looked at how well those 2 models overlap. And so anytime moving forward, if you see yellow on the slide, that means I'm talking essentially about the ground and aerial surveys. If you see blue, I'm talking about our modeling effort, and purple is kind of the conclusion stuff. So for establishing survey units, we first, to conduct the field surveys, we first had to establish survey units. To do that, we defined what we'd call potential ACM habitat. And so we got in a room and we said, well, we think grizzly bears feed on moths primarily above 8,400 feet. So that's what we went with. We then buffered that by 200 meters to account for potentially any spatial error in our estimate. And then this is what that looks like across the park. So there's a ton of area, more area than we could possibly sample. And so to remove that, we used a nested grid designed to chip away at that potential habitat. And so we undertook a series of steps with that nested grid, and that created 26 survey units. So of those 26 survey units, we said that we would conduct aerial surveys to identify grizzly bear foraging at all 26 survey units, and then we would go in and ground survey 18 of those units specifically to determine grizzly bear absence or lack of grizzly bear presence or lack of presence, which is also known as absence. And then also when we're conducting these ground surveys, because we're on the ground, if grizzly bears are feeding for these moths, we can then record evidence of their presence, that being digs, scat, that sort of thing. And so our 26 aerial survey units look like this, spread across the park. And here I'll just throw all that potential habitat so you can get an idea for how much of it we were sampling. And then this is the 18 ground survey unit. So you can see we sampled broadly across the park's alpine terrain. And so we conducted aerial surveys 2019 and 2021. We first tried fixed wings in 2019, and that didn't work too well. So Two Bear Air came to our rescue, and they became who we use to conduct aerial surveys. And what's great about them and their helicopter is that they have this infrared high definition zoom video camera that also records video. So this tool is excellent for rescuing people that are lost in the wilderness or where have you, but it also works very well when applied to science for this study. So we conducted surveys every 2 weeks, and each survey consisted of 2 flights on consecutive days, and we did that from early July to mid-September when the moths are present in the mountains. The surveys occurred from 90 minutes before sunrise to about 90 minutes after sunrise, and that was to take advantage of that infrared capability of the camera. And then in total, we conducted 12 surveys of the park, if you add that up. And in total, we had 134 observations of grizzly bears, independent observations of grizzly bears digging for ACMs from those 12 surveys. To give you an example of what it looks like, on the first pass, we fly a survey unit from 8,400 feet up to 9,500 feet, which it's shown in meters there, but that's the conversion for you. And so if the terrain is significantly above 9,500 feet within that survey unit, we then conduct a second orbit of the survey terrain up higher, and we survey to the top of it. And when we fly these survey units, we try to keep it as constant as possible at a half mile from the terrain and roughly at 60 knots airspeed. And this is a video of what it looks like when we're surveying. So this is a moth aggregation, and as you can see in infrared here, there are 5 grizzly bears feeding within this aggregation. So the cameraman switches over to visible mode, and you'll see he zooms in, and he's zooming in to record and document the grizzly bears individually. So he puts the crosshairs over the bear, switches, and you can see by zooming in, clearly we are getting at the behavior of these individuals. It's not just a grizzly bear, but it's a grizzly bear clearly feeding for moths. If we're flying in a fixed wing, it's a very different observation. We can't get that detail that we can with this camera. So here it zooms in again on these 2 individuals. They're jockeying for position a little bit, independent for where they're going to feed. Then we zoom to this other individual, and clearly it's nosing around to dig for ACMs. So that's what it looks like when we're surveying. And the information we get from that camera, again, is great. I kind of alluded to it, but that crosshair. So that's actually a laser that's hitting off that bear, and it gives a precise lat-long location that we can then plug into our models. So moving on now to the ground surveys. So this was in 22. I hired a team of technicians, and we went into survey units to sample for moths specifically, and to determine whether they are present or absent. So this is what our nested grid looks like for site selection, those yellow sites being survey plots, 2 per 1 hectare cell, and technicians had the freedom to choose one of those 2 sites per cell to sample, and that was largely due to the challenging terrain access. And this is what that looks like up close. And you'll see in the inset map, there are 3 digs. So at each plot, we conduct 3 digs that are 15 meters apart. And so for each dig, we essentially mimic grizzly bears. We dig in the talus, excavate it just as they would in a 1 meter area, which approximates sort of the crater that they make. And then we use a handheld vacuum to collect the moths. We also, while we were on the ground, record a sign of grizzly bear foraging, which I had mentioned before, that being tracks, digs, scat, and bed sites. And we measure and categorize the characteristics of the talus. And this is what it looks like when a technician is beginning the sample. You can see the vacuum's in his hand. He's starting to remove talus. And then if a moth is exposed, he would vacuum it up. like this video will show. And so that bear sign on the ground that we record, in the lower left, you'll see there's a clear crater where that rock underneath is exposed and lighter. That's all the silt. So that's what a bear dig looks like. And then here's an example of an actual bear trail that's cutting through the talus. Here's a bear scat that's filled with moths, and what I've circled there is a mostly intact moth. And then here's a sort of a mansion of a bed site. This is actually, you know, this is subterranean here, so it's an area with multiple bed sites that is used by grizzly bears, and these are important because these are exposed sites, and during the heat of the day, on those very hot days, it's very hot up high. There's lots of sun, and what's dangerous to grizzly bears is overheating. So they need these places where they can seek for thermal refugia and get out of the sun. And so the presence of these features are very important for them and their use of these sites. And this is what that site looks like from the outside. So if you were just on a mountain, these are features that you wouldn't even really notice. As far as the talus goes, characterizing, if we go from left to right here and going down, we're categorizing the geological formation. So whether the talus present on site is dominated by limestone, mudstone, talus, or an igneous talus layer. We're then distinguishing talus size, whether that talus is larger or smaller than that yellow field notebook you see in all the photos. We're also documenting whether the site is adjacent to bedrock or parent material, so that'd be about 10 meters away, or whether it's in an open area in just an open talus slope with no bedrock. Then lastly, we measured talus depth. So the deeper the talus, the cooler, more stable the temperature, the better refugia and resting area that talus might be for the cutworm moths. So a little summary of our field surveys. So we conducted ground surveys in 17 of 18 survey units. We found ACM presence pretty commonly. And that was in 16 of the 17 units that we were able to sample. So well distributed. For our aerial surveys, again, we had 134 bear groups. We documented grizzly bear foraging in 13 of 26 units. Combined, the methods that we implemented identified grizzly bear foraging in 17 of 26 survey units. And that disparity between the aerial survey is because 4 survey units we documented grizzly bear digs on the ground, technicians did. And those were 4 survey units where we did not have an aerial detection. And so this is what a map of the survey units of where we detected moths looks like. So you can see between the north and south half of the park, it's pretty green. Most survey units we went to, we found moths. Where grizzly bears are foraging for them, that's a little bit of a different story, but same thing. The distribution of these sites is spread across the park, but more survey units we failed to detect grizzly bears. It doesn't mean they're not necessarily using a site, it just means that we did not detect it. And those 4 yellow survey units you see, those are those sites where we documented evidence on the ground but didn't have a detection from the air. So we then took all this field data, and the really fun part of this project was to analyze it and model where we predict cutworm moths to be across the park. And for that, for the science people in this study, I used a general linear regression model. And what that does is it takes locations where ACMs were present and absent, and it compares sort of the different features of those locations. And then uses that to predict on a scale from 0 to 1 the likelihood that ACMs are going to be found in a given area. And then secondly, I modeled the relative suitability of grizzly bear foraging areas. For this, we used a presence-only approach, which is a maxent species distribution model, which compares areas where we saw grizzly bears compares areas where we saw grizzly bears to randomly generated pseudo absence points, and again does the same thing, compares them to the features on the landscape. So there you go, kind of got ahead of myself there. I basically said everything that's on this slide previously. And for this, we said that our research predictions for this model were that ACM occurrence would increase with increasing elevation, and geology characteristics such as limestone talus, large size talus, greater talus depth, and then greater distance to bedrock. Surficial moisture, that being sort of the effect of the snow and snow melt and its impact on essentially the temperature gradient within a talus slope. Saw ACM occurrence would increase with mid-angled slopes and south and west aspects. Oops. So I generated a bunch of models, and I had 7 models that were pretty good at predicting moth occurrence. The best model included dominant rock type, that being limestone, mudstone, igneous, talus size, talus depth, talus slope position, elevation, and then superficial wetness and greenness, which is derived from satellite imagery. And it's an estimate of sort of the superficial wetness on the surface of the talus, and then the greenness would be essentially an indication of photosynthetic activity up high. And just because when you have a best model, it doesn't mean it's a good model. Oh, so sorry, something got mixed up there. But anyways, so we undertook this approach to that sort of validated the model, and we got a score that was well above 0.7. And when you have a model that's above 0.7, that effectively means that it's good at discriminating presence from absence. So our last step was we wanted to see this as a map. And unfortunately, when you're trying to map a model, you got to have data continuously over space. And so because our best model contains some point data that we collected in the field, we had to substitute a USGS layer of rock types in for our point collected data. And then also, I had to use a terrain ruggedness layer to sort of substitute some of those sort of 3-dimensional features that we tried to we categorize on a point level. And so that model you see there is what we used. And then we undertook that same approach, and again, that AUC score, that's the rank. It was above 7, so 0.7, so it's a good at discriminating. We projected that model to what would be the lowest elevation that we detected ACMs. And then this is what that map looks like across the park. And so what sticks out about this is that there are some moderate likelihoods across the park on a number of peaks, but there are definitely certain mountains that are hot spots for this activity. And in the inset map on the left, I just threw up those points that shows you sort of sites where we detected ACMs versus where we didn't. So the last step that we took to kind of look at this, that's a continuous gradient there that you saw of likelihoods. And so I needed to convert that to a binary form. And so we undertook a process where we optimized sort of what that likely versus unlikely line would be. And this is kind of a sciencey process again. And what we ended up seeing was that when we converted our model, we saw that a 12 square kilometer area of glacier is likely ACM occurrence. That area across the park is just 0.3%. And so this shows that conversion. So what this says is that glaciers a very large area, but there's a very small area for where these moths are available and attractive to grizzly bears. So then secondly, I then separately modeled that where grizzly bears are. And again, I took that maxent species distribution model approach that again models on a 0 to 1 scale. And for this approach, this package, you could only use spatially contiguous data. So again, I had to use a model that didn't include anything that we measured. And our predictions are very similar. So we said that grizzly bear foraging would increase with the probability of ACM occurrence. So effectively for this model, we incorporated that first model as a data layer. And then we said low to mid-angled slopes. So got a little lower, thinking that grizzly bears are probably less likely to be found on steeper slopes than a moth is. Again, superficial wetness, limestone talus, and then south and west aspects. We developed two models, a full model, as you can see there, very similar to our ACM model, but it has ACM occurrence, and elevation is captured within ACM occurrence again. And then just an ACM occurrence only. So we wanted to see if some of these layers have an independent effect outside of the ACM occurrence model. And then again, I picked 10 times the number of observations, so 1,340 random location is what I compared to our observations from the helicopter. And validated that model using an independent test data set of 516 grizzly bear locations that we obtained through our ground surveys, which is very useful for model validation. And again, when we did the validation, we saw on the right here that our scores were above 0.7, which means that both models are good at predicting grizzly bear foraging. And when we look at what this looks like mapped, it looks very similar with where those hotspot centers for this activity, for where grizzly bears are foraging for them, occurs. And so now finally kind of getting to the last step of this effort, we want to know where ACMs are found. How likely is it that, how pervasive is it that grizzly bears are, going to be foraging at those areas? And to try to answer this or illustrate it, we just tried to estimate that overlap between the models. And so in yellow here, that's again that binary ACM occurrence layer. And I overthrew a transparent blue layer of the grizzly bear foraging areas to show you what those green areas, those would be the areas where ACMs are predicted to be found, and we also predict that grizzly bears will be found foraging for them. So you can see quite a bit of overlap. And recall, again, that just 0.3% of glacier is predicted to be likely ACM areas of ACM occurrence. Oops, sorry, this is a little off here, but So what this says, it's a little offline there, but basically 69% of the areas of where our models say that ACMs are likely to occur, 69% of that area is predicted to be foraged by grizzly bears. And this is what that looks like illustrated a little more easily for you. So those pink areas would be those areas of where both models overlap. And so takeaway points from my research. So this is the first mapped estimate of grizzly bear foraging for ACMs across glacier. We saw that in those maps that ACM foraging by grizzly bears is occurring across the alpine, and that glacier's 3,000 meter peaks are centers for these interactions. Our max survey count was 37 grizzly bears. This is 10% of the park population, roughly. So that's 10% of the park population at one moment during this project that was packed into 0.3% of Glacier National Park. So that's a very dense, so that means that grizzly bears are pretty densely packed into these sites. So the infrared survey tool that we use from two-bear error is very useful for identifying moth aggregations. And also, I think we can see from this research that the methods that we used are very useful and for this study, and would be useful being applied more widely in the NCDE and in other grizzly bear occupied regions of the US and Canada. And one thing I'll say too about that is that since this for the folks up in Canada, We did do some work in Waterton, and I want to let you know that we did document a moth aggregation inside Waterton. So we know that these moths are present in Alberta, and then also this summer I was up in British Columbia, and we've identified sort of the first documentation of Army cutworm moths on a mountain in British Columbia as well. And so kind of a final takeaway point, I just want to talk about the potential that expanding off-trail recreation within Glacier National Park may be leading to unintentional declines in grizzly bear energy budgets at Army cutworm moth aggregations. When Don White did his research almost 30 years ago, this is something that he brought up. And so this is what, on some sites it can look like. So grizzly bears are hanging out among people that climb mountains. And they could be foraging below where people are hiking. And so if we look at visitation in Glacier National Park, Don White's research was in the mid-90s. You can see there's 1 million more people. And so clearly grizzly bears want their ACMs, but kind of a closing thought is that, so when you're out, visiting Glacier, we effectively, as people, in my opinion, I think it's come time to where, in some areas we may need to share the mountain with grizzly bears and let them feed on the food resource where there may be sort of a conflict of sorts with number of users and that sort of thing. So I want to thank project technicians that helped on this study. And I want to dedicate this work to Bert Bjorling. He was a friend, a co-worker at the Park Service, and a fantastic technician on this project. And unfortunately, he passed away shortly after field seasons ended. And so with that, I'm through and I can take any questions.
All righty. Thank you so much, Erik, for the fascinating presentation. If you have questions, please feel free to leave them in the chat and use the reactions menu to select the raise hand icon if you would like to be called on to ask your question. And I think we already have some in there. So first question for you, Erik. When a visitor came to the park on a boat cruise, the captain said they spoke how the grizzlies ate up to 20,000 ACMs daily. How's it calculated that they eat up to 20K or 40K mouse on a daily basis?
Yeah, that gentleman I talked about, Don White Jr., that came from his research, and it's very much an estimate. And so what he did is he observed grizzly bears using spotting scopes. He documented when they defecated, and he and his team went up and collected the scats, and then in the lab back home counted moths in a scat, and then basically said, we watch bears for this amount of time each day. They're, grizzly bears are active for this many more hours a day. If we do the math, here's the potential. So, that's just a number. There are potentially ways to get at a more accurate number, and that might be something that is looked at in the future, but that's the best estimate we have right now. And it's just to give an idea that, hey, like you saw in that video, there's moths flying everywhere, and grizzly bears are this great vacuum, sucking up these moths, and each one's tiny, and so they have to eat a ton to gain fat. And so that's sort of the best estimate that we currently have. And part of the reason some of that might be lacking is, these are very difficult areas to access. So it's not that easy to get an estimate on this kind of thing.
Yeah, well, that's some good food for thought. So does ACM range extend into the Cabinet Yaak ecosystem at all?
It may. That mountain range is lower. We don't really know. What I can tell you based on our model. So basically, unfortunately, this didn't make it into had a glitch with my PowerPoint, but effectively, the takeaway from the model is that, what predicts moth occurrence, or excuse me, grizzly bear foraging is that moth occurrence layer, and then low angled slope. So we're talking about, high elevation, large talus, generally limestone talus is what tends to be large in Glacier. And then these low angled slopes. So you need talus fields and you need elevation, and so Glacier National Park has that. The cabinets are are a little bit lower, and those talus fields may not be as large, and so the likelihood is definitely lower. Can't say that they're not there. No one's really looked officially. Just nowhere near the resource that it is that Glacier National Park is for these moths.
Thank you. And someone else wants to know, are they a CIS climate indicator species, and are you seeing an uptick in foraging due to the loss of whitebark pine?
They are not an indicator species. As far as whitebark pine has been called pretty much extirpated or functionally extinct for grizzly bears a number of years ago by a biologist. So grizzly bears don't really feed on whitebark pine in Glacier. Again, these are very difficult to access places. Part of the reason I'm doing this research is we don't know it, so I like to climb, and I have a grizzly bear background, so I just kind of merge those, but it's not easy to get this data. And so there's a lot that we don't know. We don't know how much grizzly bears used to feed on this in the old days, so we can't really say what the trend is or the change. Again, what I can just tell you is that grizzly bears have very flexible habitats. If whitebark pine is not having a good year, they'll seek out other foods because they sleep for half the year and they have to get fat. If they don't get fat enough, they don't reproduce. And so again, if they don't have huckleberries, they'll switch to other foods. So these moths, a moth is going to migrate. So in theory, moths are always coming to the mountains. Their numbers we know oscillate, so the amount of moths is not consistent. But also when they come to the mountains every year in Glacier, like we saw this year, it was a cold spring. A lot of the sites that they might ordinarily come to were under snow. So we don't know, when the moths show up in early July, if a mountain's covered in snow, does that mean that moths never use that site over that summer? We just have no idea. So there's lots of questions around that sort of thing.
Okay. We got another question in the chat. Did monitoring methods, helicopters a half-mile above terrain, and technicians on site have the potential to confound your results? In your opinion, how disruptive to grizzly bear behavior are these methods?
Well, I think what we're saying is, as far as like an impact, one of the things that we saw is we recorded sort of whether we had any disturbance, and across all the detections that we had, we never had an instance of where we caused grizzly bears to flee. And again, there's lots of things that we can't control in the air. Glacier is a very turbulent place to fly. If you're in a fixed wing, it's no fun. And this helicopter allowed us to do it a little more safely. And that half mile was where we were off, and we were further away, but we had pretty much no documented disturbance or loss of grizzly bear foraging by our flights. So I guess it's, and again with that infrared, the beauty about that camera is, oftentimes when you're surveying, when there's lots of deer present or bears or whatever you're surveying, when there's lots of them, they're easy to see, so you detect them. And you might often miss the single individuals. With this infrared technology, while the video I showed you showed 5, if there was one animal on that hillside, it would show up white. And so we could detect the single individuals just as well as where there were lots of them. That's part of the reason in such a short time period that we detected grizzly bear foraging at so many new areas within the park, so many areas that visitors, the millions of people and the hundreds of people that climb these mountains each year haven't documented or observed grizzly bears feeding at these sites.
Okay. I think we have one more question in the chat, and then we'll wrap up the presentation. What is your recommendation to solve the conflict that you mentioned among bear habitat and hikers? Is closing the areas where ACM congregate during congregation times a possible strategy?
Yeah, well, this is just, me speaking for myself here. You look to the park mission, and I think, always you got to recognize that, different land agencies have different mandates. And so in the parks, it's to protect the natural resource and to provide for public enjoyment. So to me, that says that it behooves the Park Service to find, that in between that accommodates both. And so, so I'm a proponent of the park going in and in a targeted fashion. Most of the places where grizzly bears are feeding on moths are fine. There's very little disturbance from climbers. There's a select number of areas of where there's quite a few people. And so what I would venture for are implementing strategies that essentially get at sharing this mountain with grizzly bears. So that may mean that maybe humans don't need to go all over the mountain, but maybe they can go on a certain part of the mountain. Maybe certain days the mountain is open to people, maybe certain days it isn't. But what that means is maybe it's certain slopes of the mountain. And so what that means is that, if we know with conflict that if humans are in a predictable location, that, effectively that's sort of a tool that bears will come to understand that. And so that might also reduce the conflict potential of somebody potentially getting hurt or displacing a bear. And so on certain mountains that are used, you do see sort of a bit of a habituation behavior where bears are not really impacted. They let people pass very close to them. There's other mountains where if you step foot on the slope where the grizzly bear is, it's going to run like you wouldn't believe because it's not expecting us to be there.
Awesome. I did notice we have some hand raised, but I think all those went down. Very last question in the chat is, any close encounters with bears during research?
No, not really. I mean, there's one site where we had technicians that kind of got in the middle of bears, but, we didn't have any issue. Again, we didn't have any, where we had to leave or the bears had to. Everything went smoothly. And, what I didn't talk about is kind of my background, to pull off this project. I've spent a heck of a lot of time in Glacier. I know it really well, on trail and off. And so I'm very familiar with these sites. And I've spent a lot of time on them. I'm very comfortable, and I know where they like to bed down, and that's very important. When they're out in the open, these are sites that, I think, there's a lot of sows cubs, but, part of the reason sows and cubs might be at these sites is that offers a view shed, and that's important for sows and cubs for safety, for protecting and raising that cub. And so when they're foraging, they're very visible. It's when they're bedded down that you can potentially surprise a bear. And so I know what these features are, and I would instruct the technicians that we had of where they need to be careful, how to sort of access that site so that we avoided any conflict. So I'm happy to say that my team did that.
Awesome. Well, thank you, Erik, for answering all those questions. And thank you, everyone, for your great questions. We are going to close out the session now. We want to thank everyone again for joining us today. Thanks so much to Erik and our planning and tech team. Be sure to join us tomorrow at noon for a great presentation from Dr. Peter Dawson of the University of Calgary and Edwin Knox, formerly of Waterton, on digitally preserving culturally modified trees in Waterton Lakes National Park. We are interested in your feedback on the webinar, audio and video quality. Please feel free to share your comments or additional questions on this presentation with us at crownrlc@nps.gov. Thank you and have a great day.
Thank you.